I'm Anil Kumar sharing with you solution of a question which has been posted by my student Rayat. The question here is on rational functions. It says sketch the graph of y equals to a to the power of 4 minus 5a square plus 4 divided by a square minus a minus 2. So let us see how to sketch the graph of this rational function. Now this is a rational function since we have a polynomial of degree 4 and a polynomial in the numerator divided by another polynomial. The polynomial in the numerator is of degree 4 and in the denominator is of degree 2. And therefore, we do not have any horizontal asymptote in this, correct? So that is what we analyze. Now before getting into sketching, let me factor this and try to simplify. So first step for me is to simplify, okay? Okay, let's simplify. To simplify, what should I do? I should factor. So we are also learning the steps to solve such question, right? So simplify means to factor. So let's begin. Let's copy this question, which is y equals to a to the power of 4 minus 5a square plus 4 divided by a square minus a minus 2. Now this could be written or thought of as a quadratic equation, right? Where a square is the term. Now we're looking for a product of 5 and sum of minus 5. So it could be written as, product of 4, which is 4 times 1, both negative, will give us sum of minus 5. So I could write this as a square minus 4 times a square minus 1 divided by this portion, product of minus 2, sum of minus 1. So 2 times 1, 2 being negative, right? So a minus 2 times a minus 1. These two could be further factored as a plus 2 times a minus 2 times a plus 1 times a minus 1. Difference of squares, right? And then we have a minus 2 times a minus 1. Well, some of you should review factoring techniques when you get into rational functions, as without that you cannot really solve them, right? So these cancel out. Okay, so we say this is equal to a plus 2 times a plus 1. Now if I do that, am I right or there is a mistake, right? Check my mistake. So give a moment to this, check my mistake. So if I say this rational function, this is a rational function, right? This is a quadratic function. It could have zeros, but this one has no zeros. Is it same? Well, it is not same. It has some restrictions. So we should write that. So that is a is not equal to 2 and a is not equal to 1. So once I write that, then it is corrected. Do you get an idea, right? So that is how it should be. So when we say a is not 2 and a is not 1, it really means what? It means that if I substitute 2 here, then I should get a whole, right? So at these points we expect a whole, and at 1 also we expect a whole. Do you see that? That is what it means. Now we have a simplified version and it's easy to sketch from here, right? So what we will do here is sketch the graph. Okay, so this seems to be a parabola which opens upwards with two zeros, one at minus 2, the other one is at minus 1. Now since my zeros are on the left side, I'll kind of sketch it like this. Is it okay? Does it make sense to you? Okay, so we're trying to sketch a function. Let me write this function as f of x equals to a plus 2 times a plus 1, where a is not equal to 2 and 1, right? That is what we're trying to sketch. So when a is our parameter, we'll use a, not x-axis, and here we'll write f of x. Do you see that? Okay. Now we can find what f of 0 is. F of 0 is 0 plus 2 times 0 plus 1, which is indeed 2. So the y-intercept is at 2, right? That is important to understand. Second, a cannot be 2. So if I write 2 here, I get what? I get 2 plus 2 times 2 plus 1, which is 2 plus 2 is 4. 4 times 2 is 8. And then f of 1 is equals to if I write 1 here, I get 1 plus 2 times 1 plus 1, which is 3 times 2, 6, right? So this, you should remember that this is not equal to this. Is it okay? So these two are holes for us. Okay, so I just filled in all the space. Anyway, so what we have here is two holes. Okay, so we have a hole at these 2 points, which is 2, 8, and the other one is at 1, 6. Does make sense to you? Okay, so I actually ate away all the space which I thought I will use. Anyway, so what we can do is we can make another scale. Sorry for that. So let me just make another scale. We still have some space to work with. Okay, not a bad idea to make a new graph. Correct. So what we have here is that we have x intercepts at x equals to 2, minus 2, and minus 1. So we have two zeros, right? Minus 2 and minus 1, let's say. I have a 0 at minus 2, right? We have a 0 at minus 1. And we need to sketch this graph, and we know we have two holes here. One is at 2, 8, and one is at 1, 6, right? And we also know that we have y-intercept at 2. So that is the information which we know about this graph. With that, let us sketch it. So I'll just make a rough sketch, and then we'll just fill it in. So let's say the graph is kind of, let me just go like this. Okay, so we are concentrating on these two zeros, and then we are kind of going like this. Is it okay? Like this is our graph. However, as you understand, we have two holes. That means a hole at 1. So let this be 1 for us. Okay, let this be 1. So we have to make a hole here, right? A hole at 1, and let this be 2 for us. So a hole at 2 and a hole at 2, right? And the location at 2 is at 8. Is it okay? And this is my y-intercept, which is at 2. So this is at 2. Do you understand? So that is my 2, and this place seems to be hole at 1. This seems to be at 6, and this seems to be, well, not be so accurate. But anyway, when you do it on the graph paper, you get a graph like this. So finally, when you sketch it, you should sketch with these zeros, right? So the graph will be kind of like this. Do you see that? Zeros, I mean the holes, correct? And the zeros. This is how you're going to sketch. So this rational function, where this x-axis is a, and let me write this rational function as y equals to a to the power of 4 minus 5a squared plus 4 divided by a squared minus a minus 2 will be shown like this, simplified as a parabola with two holes. Do you see that? These are the two holes. So what you get here is a set of holes, right? So these are the holes. Let me point this out. Okay, these are the holes. So I hope with this video you understand how to sketch some rational functions which could be simplified like a parabola with holes, as we just did in this video. I'm Anil Kumar, and I hope this solution helps many more. Let me again thank Ryan for sharing such a beautiful question. Thank you, and all the best.